The Great Pyramid stands as an enigma carved in stone, rising from the Giza Plateau with a precision that seems to defy the primitive tools attributed to its builders. You've heard the conventional story. Around 2580 BCE, Pharaoh Khufu commanded thousands of laborers to erect this monument as his eternal tomb. Yet as you stand before this massive structure, something doesn't quite add up. Conventional archaeology tells a straightforward narrative, but as centuries passed and desert winds polished limestone blocks, quiet voices began to challenge this accepted timeline. Could it be that the Great Pyramid, the last of the seven wonders still standing, was not built by Khufu's people at all, but inherited from a far older world, one that existed before the end of the last ice age? The idea is as staggering as it is unsettling. To entertain it requires bending the timeline of civilization backward by several millennia, past the dynasties of Egypt, past the invention of writing, even past the birth of agriculture. It means imagining a world that flourished before the Younger Dryas, a sudden and violent climatic event that began around 12,900 years ago and ended about 11,700 years ago. During this cataclysmic period, global temperatures plummeted. Ice sheets surged and sea levels rose in catastrophic pulses. For reasons still debated, something, perhaps a comet, perhaps a shift in ocean circulation, threw the planet into chaos. Civilizations, if any existed, would have been erased almost overnight. Dr. Mark Lehner, the Harvard Egyptologist who has spent 4 decades studying the Giza monuments, admits the puzzles are troubling. Though a defender of conventional dating, even he acknowledges the technical anomalies. The precision we see at Giza exceeds what we might expect from the supposed period. When I examine the tool marks, the alignments, the mathematical relationships, there are aspects that challenge our understanding of Old Kingdom capabilities. In the quiet halls of geology and archaeology, the notion of pre-Diluvian origins has long been dismissed as fantasy. Yet as new evidence emerges from the very bedrock of Giza, the ancient sands appear to whisper a different story. The weathering on the Sphinx enclosure, the alignment of stars frozen in an ancient sky, and the mathematical perfection of the Great Pyramid have all forced researchers to reconsider what they thought they knew about human history. Christopher Dunn, a precision engineer who has spent decades analyzing the machining marks at Egyptian sites, makes startling observations about the granite work. These blocks show tool marks consistent with feed rates that would require cutting speeds far exceeding what bronze or copper implements could achieve. We're looking at surface finishes and geometric precision that match modern industrial standards. If these structures were built before the Younger Dryas, they were constructed by hands that predate recorded time, by engineers who vanished with the flood that ended an age. The modern history of pyramid dating begins in the 19th century, when Egyptologists first linked the monuments to the Old Kingdom using inscriptions found near the Great Pyramid. They confidently attributed the structure to Khufu, yet radiocarbon tests performed on organic materials came not from the pyramid's interior stone, but from later repairs and settlement layers. This absence of definitive proof has left an unsettling gap between geological and historical records, a gap that some researchers believe may stretch back thousands of years further than anyone dares to admit. The Giza Plateau itself tells a story older than pharaohs. Before the desert hardened into what we see today, this region was once fertile, lush, and drenched by seasonal rains. Dr. Robert Schoch, the Boston University geologist who first proposed the water erosion hypothesis, presents compelling evidence that challenges orthodox chronology. The vertical undulations carved into the Sphinx enclosure could not have formed in a desert climate. Water, not wind, produces these smooth, rounded channels. This weathering pattern points to an era when torrential rains fell on Giza, possibly between 9,000 and 7,000 BCE, or even earlier. The limestone cliffs and bedrock, when analyzed closely, show patterns of deep, rounded erosion caused not by wind, but by heavy, persistent rainfall. Such weathering could not have occurred in Egypt's arid climate of the last 5,000 years. According to Schoch's analysis, these marks point to an era when the region experienced tropical monsoons, conditions that ended around the time of the Younger Dryas. If true, the Sphinx, and perhaps the pyramids themselves, must have already been standing, exposed to the rains of a vanished climate. Mainstream scholars argue otherwise, maintaining that the weathering could result from groundwater or salt crystallization. The debate has grown fierce, dividing geologists from Egyptologists in a rare cross-disciplinary conflict. Still, the data refuses to settle. Seismic readings beneath the plateau hint at hidden chambers. The precision of Giza's layout mirrors the belt stars of Orion, as they appeared around 10,150 BCE. The pyramid's base is oriented to true north, with an accuracy that modern surveyors find remarkable, less than 1/15 of a degree deviation. Considering the supposed tools of the Fourth Dynasty, each clue taken alone could be dismissed as coincidence. Together, they begin to form a pattern that strains the boundaries of conventional history. You might wonder about the connection between these ancient monuments and the land you call home. The answer lies in patterns that stretch across continents, defying conventional explanations of independent development. In Ohio, the Serpent Mound extends for nearly a quarter mile, its curves precisely aligned with lunar cycles and solstices. This earthwork, constructed by the ancient Adena, people around 1000 BCE, demonstrates astronomical knowledge rivaling that of Egypt. Even more intriguing, when mapped on modern coordinates, the Serpent Mound sits on geodesic lines that connect to other ancient sites worldwide. The spacing follows precise angular divisions, 30, 45, and 60 degrees, suggesting someone understood Earth's geometry on a planetary scale. These aren't random coincidences. The mathematical relationships between sites separated by thousands of miles and thousands of years point to shared knowledge systems. The first whispers of an older civilization beneath Egypt's sands date back to Greek historians. Herodotus wrote that the Great Pyramid was built over a vast subterranean labyrinth, its entrance guarded by water channels and hidden machinery. Later, Arab chroniclers repeated tales of ancient kings who built the pyramids not as tombs, but as vaults of wisdom, sealed before a coming flood. For centuries, these accounts were treated as myth. Yet modern ground-penetrating radar surveys have revealed anomalies beneath the plateau, large cavities and geometric voids that remain unexplored. Whether natural or artificial, they echo the forgotten legends that once linked Giza to an antediluvian world. In 2017, Muon tomography discovered a previously unknown void above the Grand Gallery, roughly 100 feet long, perfectly centered within the pyramid's body. Its symmetry suggests deliberate construction, yet its purpose remains unknown. If the pyramids truly predate the Younger Dryas, they would belong to a time when the last remnants of Ice Age humanity roamed the Earth. This was an age when great glaciers still covered much of the northern hemisphere, yet pockets of advanced culture may have thrived in temperate zones. Some scientists have speculated that early societies, perhaps coastal and maritime in nature, could have developed far earlier than conventional timelines suggest, only to vanish beneath rising seas at the end of the Pleistocene. Such a civilization, stripped of its coastlines, would have left few traces beyond megalithic enigmas scattered across the world, from Göbekli Tepe in Turkey dated to 9600 BCE, to the sunken ruins off the coast of India, the connection between these sites suggests more than coincidence. According to researchers studying global monument networks, the architectural motifs, astronomical alignments, and mathematical ratios found in Egypt appear again in distant places, even in North America. The ancient copper mines of Michigan's Upper Peninsula tell a remarkable story that challenges assumptions about prehistoric American capabilities. For over 4,000 years, from roughly 3000 BCE to 1200 CE, indigenous peoples extracted an estimated 1.5 billion pounds of pure copper from Lake Superior's shores. This metal, archaeologists have discovered, was traded across vast networks stretching from the Atlantic to the Pacific. The scale of these operations rivals anything achieved in the ancient world, yet predates the supposed European discovery of the Americas by millennia. The mining operations required sophisticated engineering. Prehistoric miners used fire-setting techniques, heating rock faces, and then rapidly cooling them with water to create fractures. They excavated shafts hundreds of feet deep, complete with timber supports and drainage systems. The precision of their extraction methods suggests knowledge of metallurgy and geology that Orthodox history doesn't credit to hunter-gatherer societies. At Cahokia, near present-day St. Louis, the largest prehistoric settlement north of Mexico once housed between 15,000 and 20,000 people at its peak, around 1100 CE. Its central mound, Monk's Mound, covers 14 acres and rises 100 feet, a structure requiring sophisticated engineering and astronomical knowledge. The earthwork contains over 22 million cubic feet of soil, all moved without wheeled vehicles or draft animals. The site's layout mirrors celestial patterns, with plazas and mounds aligned to solstices and equinoxes with the same precision found at Giza. The builders understood not just astronomy, but also hydrology. They engineered drainage systems and flood controls that allowed dense urban populations to thrive on the Mississippi floodplain. Carbon dating places the site's construction within the medieval warm period, when favorable climate conditions supported large-scale agriculture and monument building. The Cherokee, Lakota, and dozens of other tribal nations preserve detailed accounts of global floods, star-born teachers, and the destruction of earlier worlds. These are not primitive myths, but sophisticated historical records passed down through oral tradition with remarkable consistency. They speak of times when the earth was different, when great waters covered the land, and when the survivors had to rebuild civilization from scattered fragments. The Hopi speak of previous worlds destroyed by fire and flood. The Ojibwe tell of a great deluge that forced their ancestors to migrate westward. Mayan texts describe multiple world ages ending in catastrophe. These narratives, preserved independently across vast distances, share striking similarities with flood legends from Mesopotamia, India, and Egypt, suggesting common origins in actual historical events rather than mere mythological imagination. To mainstream archaeology, these suggestions border on heresy. Civilizations are thought to arise independently, separated by geography and time. But if even a fragment of this pattern proves true, it would imply that the builders of Giza were not isolated dreamers of the Nile, but inheritors of a global legacy that once included the sophisticated cultures of ancient America. New discoveries continue to complicate the picture. Core samples taken from the Nile Delta show sudden layers of flood sediment dated to the end of the Pleistocene, consistent with massive meltwater surges. At the same time, erosion data from the Giza Plateau suggest exposure to precipitation long before the Sahara's desertification. The convergence of geology and myth has begun to erode the once solid walls of traditional chronology. When you examine the Great Pyramid's interior, the precision becomes even more astounding. The so-called King's Chamber is built entirely from massive blocks of granite transported from quarries hundreds of miles to the south. Each block weighs between 25 and 80 tons, and the chamber's dimensions follow mathematical symmetries that mirror the exterior. Above it lies a series of relieving chambers, their configuration forming patterns of resonance as though designed to manage not just physical stress, but acoustic vibration. Engineers who have studied the structure note that the granite's crystalline composition allows it to respond to sound frequencies in ways that suggest awareness of acoustic properties unknown to the ancient world. Christopher Dunn's analysis reveals that sound experiments conducted inside the king's chamber produce standing waves, tones that reverberate at specific frequencies. The granite sarcophagus at its center resonates at 438 Hz, close to the A note used in modern musical tuning. The same harmonic proportions that produce this resonance correspond to ratios used in classical music and modern architecture alike. When multiple frequencies interact within the chamber, they generate harmonic overtones, amplifying and sustaining sound in ways that seem almost intentional. If deliberate, this would suggest knowledge of physics and acoustics centuries ahead of its time. The mystery deepens with the question of tools. No definitive evidence of copper chisels capable of cutting hard granite has ever been found at the site. According to Dunn's detailed analysis, the saw marks on certain blocks display uniform spacing, suggesting the use of advanced cutting tools, possibly with blades embedded with harder materials like quartz or corundum, substances not documented in Egyptian metallurgy of the Old Kingdom. Drill cores examined under microscopes reveal spiral grooves consistent with high-speed rotary tools. Some samples indicate feed rates and pressures comparable to modern machinery. Dunn's research demonstrates that these patterns cannot be replicated using the copper tube drills and sand abrasion methods traditionally attributed to ancient Egyptian craftsmen. If the builders possessed tools or techniques more advanced than copper chisels, where did they come from? This question lies at the heart of the hypothesis that the Giza structures may represent inherited technology. Perhaps these methods were not invented by Khufu's laborers, but preserved by oral tradition from an earlier era, a civilization that had long since fallen, but whose knowledge endured in secret. Such an inheritance might explain not only the engineering anomalies, but the cultural reverence with which later Egyptians treated the monuments. The connection between vibration and sacred architecture isn't unique to Egypt. Throughout the Americas, indigenous builders created structures with remarkable acoustic properties. The ball court at Chichen Itza amplifies whispers to thunderous echoes across its 545-foot length. The Maya understood that the design would create these effects, intentionally engineering acoustic phenomena that enhanced ceremonial activities. The kivas of Mesa Verde, circular ceremonial chambers built by ancestral Puebloans between 600 and 1300 CE, demonstrate sophisticated acoustic design. These underground spaces resonate with human voices in ways that enhance meditation and ceremony. The builders oriented these chambers to cardinal directions and included features like deflector stones and sipapu holes that affect sound propagation in measurable ways. Even the massive earthen mounds of Cahokia show evidence of acoustic engineering. Recent studies using ground-penetrating radar have revealed buried chambers within some mounds that appear designed to focus and amplify sound. These features suggest that the builders understood not just astronomy and hydrology, but also the physics of sound propagation. As night falls over Giza, the stars awaken above the desert like ancient witnesses returning to their posts. The three pyramids rise from the darkness, their silhouettes aligned with a precision that mirrors something far greater than human ambition. When viewed from above, their layout bears an uncanny resemblance to the three stars of Orion's belt, Alnitak, Alnilam, and Mintaka, those gleaming points in the constellation of the celestial hunter. This observation, first detailed by Robert Bauval in his Orion correlation theory, suggests that the pyramid's spatial arrangement corresponds to Orion's belt, not in the sky of today, but in the sky of roughly 10,150 BCE. At that time, due to the precession of Earth's axis, Orion's belt would have appeared at its lowest point on the horizon, perfectly matching the pyramid's configuration relative to the ancient Nile River, which in astronomical terms mirrors the Milky Way. If true, this would place the conceptual design of Giza deep within prehistory, long before recorded civilization began. The implications are staggering. It suggests that whoever planned the complex possessed astronomical knowledge requiring centuries of precise observation. Such knowledge presupposes an advanced scientific culture that mainstream history says did not yet exist. The precessional cycle of Earth, roughly 26,000 years long, is a phenomenon requiring long-term data collection. The slow drift of the stars is imperceptible within a single lifetime. It can only be tracked through meticulous observation across generations. The builders of Giza, or those who taught them, must have understood this grand cosmic rhythm. This understanding may have roots that stretch back to Ice Age observers who charted the heavens long before writing was invented. Egyptian temples were known as houses of the horizon, places where the heavens met the earth. Their axes were determined not only by stellar observation, but by a concept called meridian, the line of balance. The Great Pyramid sits near the intersection of the longest land meridian and the widest parallel, almost at Earth's geographical center. From this position, its builders could theoretically derive measurements applicable to the entire planet. This understanding may have roots in the Americas as well. The ancestral Puebloans of Mesa Verde constructed astronomical observatories with sight lines precisely aligned to solstice and equinox positions. At Casa Rinconada, a great kiva built around 1070 CE, 28 wall niches correspond exactly to the lunar month cycle. During summer solstice, sunlight enters through a strategically placed window and illuminates specific wall features, creating a natural calendar system. Their knowledge of celestial mechanics allowed them to create agricultural calendars accurate to the day, essential for survival in an unforgiving high desert landscape. Like the pyramid builders, they understood that observing the heavens was key to mastering life on Earth. The precision of their astronomical alignments rivals anything found in the Old World, challenging assumptions about the sophistication of pre-Columbian American science. At Chaco Canyon, the ancestral Puebloans built Pueblo Bonito, a massive complex containing over 800 rooms and rising 4 stories high. The building's design incorporates sophisticated astronomical alignments. Its walls and doorways frame the rising and setting points of significant celestial bodies throughout the year. The builders understood not just the solar cycle, but the complex 18.6-year lunar standstill cycle, knowledge that required generations of careful observation. At the twilight of the Pleistocene, the world experienced one of the most abrupt transformations in geological history. Around 12,900 years ago, the climate suddenly reversed course after millennia of gradual warming. Earth plunged back into cold, global temperatures dropped by as much as 8 degrees Celsius, and vast regions once blooming with forest returned to tundra. The Younger Dryas stands at the center of one of history's greatest mysteries. Geologists continue to debate its cause, but mounting evidence suggests a cosmic impact triggered the catastrophe. In 2007, researchers identified a black matte layer in sediment cores across North America, a carbon-rich deposit containing microscopic diamonds, platinum, and spherules consistent with extraterrestrial impact. This impact hypothesis gained support when scientists discovered elevated levels of platinum in ice cores from Greenland, dated precisely to the onset of the Younger Dryas. Platinum is rare in Earth's crust, but common in asteroids and comets. The spike suggests that something from space struck our planet with devastating force around 12,900 years ago. The impact likely occurred over the Laurentide ice sheet covering much of North America. The explosion would have instantly vaporized billions of tons of ice, sending massive amounts of fresh water into the North Atlantic. This sudden influx disrupted ocean circulation patterns, particularly the Gulf Stream, plunging the Northern Hemisphere into a deep freeze that lasted over a millennium. The event's fingerprints are visible even in the sands of Egypt. Sediment samples from the Nile Delta show abrupt transitions, layers of flood debris laid down within a short geological window, consistent with massive meltwater surges. Around the same period, the Sahara began its transformation from green savanna to desert. Lakes that once dotted North Africa dried up or retreated underground, and populations were forced toward river valleys. Evidence for this climatic catastrophe appears in the archaeological record across North America. The Clovis culture, known for their distinctive spear points, vanished abruptly at the Younger Dryas boundary. Archaeological sites show a sudden cessation of tool production and human activity, followed by a 1,000-year gap before new cultures emerged. The megafauna these people hunted, mammoths, mastodons, giant ground sloths, and saber-toothed cats, also disappeared, victims of climate change and ecosystem collapse. If Giza's earliest monuments existed before this environmental collapse, they would have endured an epical catastrophe that buried and reshaped much of the planet's surface. Nearly every ancient culture tells of a deluge that wiped out the old world. The Egyptian version is subtler, yet it lingers in the concept of Nun, the primordial waters from which creation was reborn, and the Zep Tepi, the first time when gods walked the earth before retreating to the heavens. This global catastrophe would explain the sudden and simultaneous rise of advanced cultures after 10,000 BCE. Humanity did not invent civilization overnight. It remembered. Survivors, displaced by flood and famine, carried fragments of lost knowledge to new lands, rebuilding piece by piece in Egypt, Mesopotamia, India, and the Americas. The pyramids, ziggurats, and stepped temples that appeared on every continent may all descend from a single ancestral prototype, a style born on coastlines now drowned. You might ask what evidence exists for such advanced prehistoric societies in North America. The answer lies buried beneath layers of sediment and conventional assumptions. Recent archaeological discoveries have revealed sophisticated earthworks throughout the Ohio River Valley, some dating back 8,000 years. These aren't simple burial mounds, but precisely engineered structures requiring advanced mathematics and astronomy. The Newark earthworks in Ohio cover 4 square miles and include geometric forms, circles, squares, and octagons, connected by perfectly straight causeways stretching for miles. The Great Circle measures 1 to 200 feet in diameter, while the attached octagon covers 50 acres with walls 5 to 14 feet high. The angles between these shapes correspond to lunar cycles with an accuracy that rivals modern observatories. Archaeological investigations have revealed that the builders understood the 18.6-year lunar standstill cycle, the complex pattern of the moon's rising and setting positions over nearly 2 decades. To create monuments encoding this knowledge required not just organization and labor, but sophisticated understanding of celestial mechanics passed down through generations of careful observers. What's remarkable is how these American earthworks share mathematical principles with monuments worldwide. The same geometric ratios, the same astronomical alignments, the same understanding of Earth's curvature appear from Ohio to Egypt to Peru. The builders of Newark used the same 366-degree measurement system found in ancient Egypt and Mesopotamia, suggesting shared origins in a common mathematical tradition. At Poverty Point in Louisiana, built between 1700 and 1100 BCE, concentric ridges form a partial octagon covering 200 acres. The site's design incorporates astronomical alignments and demonstrates sophisticated engineering. The builders moved an estimated 1 million cubic yards of earth without wheeled vehicles or draft animals. Trade networks centered here reached from the Great Lakes to the Gulf Coast, distributing copper, obsidian, and other exotic materials across thousands of miles. The scale of these earthworks challenges conventional assumptions about hunter-gatherer societies. Poverty Point required coordinated labor from hundreds of people over decades, suggesting complex social organization and shared spiritual or scientific purposes. Like Giza, these monuments seem designed not for practical habitation, but for observing and commemorating cosmic cycles. The Great Pyramid's precision extends far beyond its exterior. Deep within its mass lies the King's Chamber, whose dimensions form a perfect double cube. When modern physicists analyzed its electromagnetic properties in 2018, they discovered that at specific frequencies between 200 and 600 meters wavelength, the pyramid can concentrate electromagnetic energy in its internal chambers and beneath its base. This effect results from the structure's precise geometry and limestone composition, which together form a natural resonator. The limestone casing, now mostly stripped away, once contained high levels of quartz, a piezoelectric mineral that converts pressure into electrical charge. Beneath it, the granite core also contains quartz, arranged in blocks fitted so precisely they could transmit vibration like circuit components. The earth itself hums with energy. Beneath the crust, electric currents flow through molten metal, generating magnetic fields that stretch far into space. Lightning strikes send pulses of electricity through the ionosphere every second of every day. If one could tap into this vast web, one could theoretically draw energy from the planet itself, a concept modern inventors have pursued for centuries, from Nikola Tesla's wireless transmission experiments to contemporary research into atmospheric electricity. Some researchers suggest that water channeled beneath the pyramid might have provided a natural source of vibration and static potential. The Nile, in ancient times, flowed closer to Giza than it does today. Hydraulic pressure and flowing water could have created the piezoelectric effects needed to generate measurable electromagnetic fields within the structure. Whether intended or accidental, these electromagnetic properties add another layer to the pyramid's mystery. Modern acoustic studies reveal that the King's Chamber produces standing sound waves when excited by low frequencies, creating an audible hum that resonates through the granite walls. The chamber behaves like a precisely tuned instrument, responding to specific frequencies in ways that suggest either remarkable coincidence or deliberate acoustic design. This connection between ancient architecture and natural forces appears throughout the Americas as well. At Serpent Mound in Ohio, researchers have detected subtle magnetic anomalies along the earthworks curves. The mound follows natural ridges that concentrate geomagnetic fields, suggesting the builders selected sites based on energetic properties as well as astronomical alignments. The indigenous peoples of the Americas understood that certain locations possessed special qualities, places where the Earth's energy could be felt and harnessed. Sacred sites from the Pacific Northwest to the Amazon consistently occupy positions where geological features create measurable electromagnetic effects, from underground water flows to mineral concentrations that affect local magnetic fields. To understand how such precision was achieved thousands of years ago, we must reconsider our assumptions about prehistoric capabilities. Each of the pyramids' estimated 2.3 million blocks weighs between 2 and 70 tons, some carved from granite quarried hundreds of miles away at Aswan. The logistics of quarrying, transporting, and positioning such stones remains one of history's most profound riddles. The blocks are fitted so tightly that a razor blade cannot pass between them. Modern laser scans show that the pyramid's base is level to within less than 2 centimeters across 13 acres, a tolerance unmatched by any modern skyscraper. The corner angles deviate from perfect alignment by less than 1/15 of a degree, and the entire structure remains oriented almost perfectly to true north, achieved before the invention of the magnetic compass. How could teams of laborers using simple tools align multi-ton stones to within fractions of an inch? The massive material required to build ramps high enough to reach the pyramid's apex would have exceeded the volume of the pyramid itself. Yet no remains of such massive ramps have ever been found. Some researchers propose that the builders exploited natural forces, perhaps using water-filled channels or hydraulic systems to move heavy stones with minimal human effort. Archaeological evidence suggests that the Nile once flowed much closer to Giza than it does today, potentially allowing river transport directly to the base of the plateau. In 2013, papyrus fragments discovered at Wadi al-Jarf revealed details of limestone transport during Khufu's reign, describing boats carrying blocks down the Nile to a harbor near the pyramid site. Sediment analysis has revealed traces of this ancient harbor, long buried by sand, with channels connecting the site directly to the river. But even with water access, lifting multi-ton blocks into precise alignment would have required methods far beyond human muscle alone. Christopher Dunn's analysis of the granite work reveals surface finishes and geometric precision that challenge conventional explanations. The interior surfaces of the granite boxes in the Serapeum at Saqqara, for instance, are so perfectly flat and square that they meet modern machining standards. The precision extends to the pyramid's interior, where ascending and descending passages intersect at exact right angles. Their gradients match trigonometric ratios corresponding to astronomical constants. The Grand Gallery rises like a tunnel toward the heavens, its corbelled roof narrowing upward with geometric precision that distributes weight while creating perfect acoustic resonance. This architectural knowledge appears centuries ahead of its time. The Great Pyramid seems to have been designed not through trial and error, but through understanding of harmonic geometry, a system uniting mathematics, astronomy, and material science. In such a system, precision arises not from technological sophistication alone, but from coherence of design that mirrors natural laws. Even more puzzling is the apparent decline in building technology after the Great Pyramid. Later pyramids, built under well-documented pharaohs, display inferior craftsmanship, crooked lines, collapsing interiors, and inconsistent dimensions. If the Great Pyramid were truly the pinnacle of a developing tradition, we would expect subsequent constructions to improve, not deteriorate. Instead, the opposite occurred, as if knowledge was being lost rather than accumulated. This pattern of technological regression appears in other ancient sites worldwide. The earliest megalithic structures often display the greatest precision, while later attempts show declining skill. At Pumapunku in Bolivia, the oldest stone blocks are cut and fitted with tolerances measured in fractions of millimeters, while more recent additions show cruder workmanship. The same pattern appears at Sacsayhuaman in Peru, where different construction phases show dramatically different levels of sophistication. In North America, the earliest earthworks display remarkable precision and scale, while later mound-building cultures produced smaller, simpler structures. The massive geometric earthworks of the Adena and Hopewell cultures gave way to smaller burial mounds and village sites. It's as if successive generations inherited monuments they could maintain, but not truly comprehend, gradually losing the scientific knowledge encoded in their design. This backward trajectory remains one of archaeology's strangest puzzles. How could civilizations that achieved such precision in their earliest works decline in capability within generations? One explanation is that these cultures were drawing upon inherited knowledge, a legacy from teachers who preceded them, but whose origins have been forgotten. The ancient copper mines of Michigan's Upper Peninsula demonstrate this pattern clearly. The earliest mining operations, dating to 3000 BCE, show remarkable sophistication. Deep shafts with timber supports, complex drainage systems, and extraction techniques that maximized copper yield while minimizing waste. Later mining efforts, though substantial, never matched the engineering sophistication of the earliest workings. Genetic studies of ancient remains from the Great Lakes region reveal complex ancestry, including populations that migrated during the early Holocene. These findings align with the idea of post-catastrophic movement of peoples carrying specialized knowledge into new territories. Their integration with local populations could have sparked sudden technological advances, followed by gradual decline as the original knowledge was diluted or lost. The builders of America's great earthworks may have inherited astronomical knowledge from teachers whose origins stretched back to the Ice Age. Like the pyramid builders of Egypt, they possessed understanding that exceeded their supposed technological capabilities, creating monuments that encoded cosmic knowledge for future generations to decipher. Perhaps the pyramid was meant as a repository of measurement, an enduring record of Earth's proportions, designed to survive floods, wars, and time itself. Its builders may have known that civilizations rise and fall like waves, but geometry endures. If they could encode their knowledge into stone, in ratios that echo Earth itself, they could communicate across time using mathematics as a universal language that transcends culture and epoch. The Great Pyramid's dimensions reveal this encoded knowledge with startling precision. When the monument's height is multiplied by 43,200, a number representing the ratio of Earth's axial precession, the result approximates the planet's polar radius. When the base perimeter is multiplied by the same factor, it yields Earth's equatorial circumference. These correlations are accurate to within less than 1%, suggesting direct knowledge of planetary geometry millennia before such measurements could have been empirically obtained. The pyramid's internal geometry continues this theme of cosmic encoding. The king's chamber dimensions form a perfect 1.2 ratio, a double cube whose proportions generate the golden ratio when its diagonal is calculated. This same ratio appears throughout nature, from nautilus shells to galaxy spirals, representing a fundamental constant of growth and harmony that the ancients somehow understood and preserved in stone. Even the pyramid's slope angle of 51.84 degrees yields the mathematical constant pi when the relationship between height and base perimeter is calculated. This cannot be accidental. It indicates deliberate intention to encode fundamental mathematical relationships into the structure's very form. The builders transformed abstract cosmic principles into physical reality, creating a monument that functions simultaneously as architecture, mathematics, and astronomy. This obsession with mathematical perfection extends beyond Egypt to monuments worldwide. At Angkor Wat in Cambodia, built in the early 12th century, the temple complex mirrors the astronomical cycles of Hindu cosmology. The central tower represents Mount Meru, the cosmic axis, while the surrounding structures encode the periods of various celestial bodies. The temple's measurements correspond to Earth's dimensions using the same scaling factors found at Giza. In the Americas, this mathematical tradition appears at Teotihuacan, where the Pyramid of the Sun's base dimensions relate to Earth's circumference, using ratios nearly identical to those found in Egypt. The Avenue of the Dead aligns with stellar positions, while the complex's layout mirrors the solar system's proportions. These parallels suggest shared knowledge systems that transcended geographical and cultural boundaries. The builders of these monuments understood that knowledge encoded in stone could survive catastrophes that destroy libraries and cities. Unlike written texts, which depend on living languages and cultural continuity, mathematical relationships embedded in architecture remain decipherable to any civilization capable of measurement and calculation. Dr. Robert Schoch's geological analysis provides a timeline for when this encoding might have occurred. The water erosion patterns on the Sphinx suggest exposure to heavy rainfall during the African humid period, which ended around 5,000 years ago in northern Egypt, but persisted longer in equatorial regions. If the Sphinx predates this climatic shift, it could be 7,000 to 9,000 years old, placing its construction in the early Holocene, when global climate was still recovering from Younger Dryas disruption. This timeline aligns with the emergence of sophisticated astronomical knowledge worldwide. Nabta Playa, located 100 kilometers west of Abu Simbel, contains stone circles dated to 6,000 to 4,000 BCE that track stellar alignments with remarkable precision. These monuments predate Stonehenge by millennia, demonstrating that African peoples were practicing advanced astronomy long before European megalithic construction began. The astronomical alignments at Nabta Playa include sight lines to Sirius, whose heliacal rising coincided with Nile floods, and to stars in Orion's belt. The builders understood precession and encoded multiple stellar cycles into their stone arrangements. When the site was abandoned around 4000 BCE, possibly due to increasing aridity, its astronomical knowledge may have migrated eastward to the Nile Valley. Similar astronomical sites appear throughout the Americas during this same period. Medicine wheels on the Great Plains, petroglyphs in the southwest, and shell rings along the Atlantic coast all demonstrate sophisticated understanding of celestial mechanics. The Bighorn Medicine Wheel in Wyoming, built around 1,000 years ago, aligns with sunrise and sunset positions during summer solstice, as well as the rising points of bright stars like Aldebaran and Sirius. These monuments suggest that ancient peoples worldwide shared an urgent need to preserve astronomical knowledge in permanent form. Perhaps they understood that their observations, accumulated over generations, could be lost if not encoded in imperishable materials. Stone circles and earthworks became libraries of cosmic knowledge, designed to survive climatic catastrophes and cultural upheavals. The pattern extends to the southern hemisphere as well. At Machu Picchu in Peru, the Intihuatana stone functions as a precise astronomical instrument, its angles aligned to track solar positions throughout the year. During winter solstice, the stone casts no shadow at noon, demonstrating the builder's sophisticated understanding of Earth's relationship to the sun. Similar hitching posts of the sun appear at other Incan sites, suggesting widespread knowledge of astronomical principles. This global distribution of astronomical monuments implies either independent discovery of the same principles or transmission of knowledge between distant cultures. Given the mathematical precision and consistent use of specific ratios, transmission seems more likely than coincidence. The monument teaches that the search for truth is cyclical, that knowledge once lost can be found again if one listens closely enough. It is a dialogue across millennia between builders who spoke through proportion and descendants who answer through curiosity. When you stand before the Great Pyramid, you're not just observing ancient history, you're participating in humanity's longest conversation about the nature of reality itself. This conversation may have begun far earlier than conventional history suggests. Recent underwater discoveries have revealed megalithic structures off coastlines worldwide, submerged when sea levels rose after the Ice Age. Off the coast of India, sonar surveys have detected geometric formations stretching for miles along the seabed at depths of 120 feet. These structures, if artificial, would predate the rise of oceanic waters by thousands of years. Similar underwater anomalies have been found near Japan's Yonaguni Island, off the coast of Malta, and in the Caribbean near the Bahamas. The so-called Bimini Road consists of rectangular limestone blocks arranged in linear formations beneath 20 feet of water. While geologists debate whether these features are natural or constructed, their geometric regularity and consistent depth suggest they were exposed when sea levels were much lower. If these underwater sites represent the remnants of coastal civilizations, they could explain the sudden appearance of advanced knowledge after the Younger Dryas. The survivors who reached inland areas like the Nile Valley and the American interior may have carried with them fragments of astronomical and mathematical knowledge developed during millennia of coastal observation. Their monuments became attempts to preserve this wisdom in permanent form, safe from future floods. The scale of sea level change supports this hypothesis. When the great ice sheets melted between 15,000 and 6,000 years ago, global sea levels rose over 400 feet, drowning vast areas that had been inhabited during the Ice Age. The Persian Gulf, the North Sea, and much of Southeast Asia's continental shelf were exposed dry land where large populations could have thrived. Any cities or monuments built in these regions now lie beneath hundreds of feet of water and sediment. Archaeological evidence from the American Great Lakes region tells a parallel story of post-glacial adaptation. As the ice sheets retreated, vast proglacial lakes formed and drained repeatedly, creating dramatic changes in water levels and geography. The peoples who lived through these transformations developed sophisticated knowledge of hydrology and climate patterns, understanding that water levels could change rapidly and dramatically. The copper mining operations around Lake Superior demonstrate this adaptive knowledge. The miners worked during periods when lake levels were lower, accessing deposits that are now underwater. They understood seasonal and long-term water cycles, timing their extraction activities to coincide with optimal conditions. This knowledge, passed down through oral tradition, allowed them to predict and prepare for environmental changes. Indigenous oral traditions throughout the Great Lakes region preserve detailed accounts of these water level changes, describing times when vast areas now underwater were dry land where people lived and worked. The Ojibwe speak of 7 fires prophecy, describing migrations and settlements along waterways that have since changed dramatically. These aren't mythical accounts, but historical records of real environmental transformations. The builders of America's great earthworks understood that their monuments needed to survive not just human conflicts, but natural catastrophes. They chose elevated locations and used construction techniques that could withstand flooding and erosion. The Serpent Mound sits on a ridge overlooking the Brush Creek Valley, positioned to remain visible even during major floods. its builders understood that low-lying areas were vulnerable to environmental change. At Cahokia, the builders constructed elaborate drainage systems and flood controls, allowing dense populations to occupy the Mississippi floodplain safely. They understood hydrology on a regional scale, engineering solutions that managed water flow across thousands of square miles. When climate change around 1200 CE brought increased flooding and social stress, these systems could no longer cope, and the city was gradually abandoned. This pattern of environmental adaptation and eventual abandonment appears throughout the archaeological record. Civilizations rise during favorable climatic periods, develop sophisticated knowledge and technologies, then face challenges when conditions change. Those that can adapt and preserve their knowledge survive to rebuild elsewhere. Those that cannot disappear, leaving only monuments as testimony to their achievements. The pyramid builders may have understood this cycle intimately. Living in the aftermath of global catastrophe, they could see evidence of dramatic environmental change all around them. The Sahara was still transitioning from grassland to desert. The Nile was still adjusting to post-glacial flow patterns. They built not for their immediate needs, but for an uncertain future, encoding essential knowledge in forms that could survive whatever changes might come. Modern climate science confirms that such dramatic changes remain possible. Ice core data shows that Earth's climate can shift rapidly between stable states, sometimes within a few decades. The Younger Dryas demonstrates that even relatively small triggers can cause global climate reorganization. The builders of ancient monuments may have been wiser than we realize in preparing for such possibilities. Their monuments stand as reminders that human knowledge and achievement are always provisional, dependent on environmental conditions that can change without warning. By encoding their understanding in stone, they created time capsules designed to communicate across whatever gaps might emerge in human memory. The structure's very austerity, its refusal to explain itself, feels intentional, as if it were designed not to commemorate one civilization, but to outlast all civilizations. Modern monuments declare their meanings loudly in languages that time will erase. The pyramid speaks in silence, using only shape and ratio. Its message requires no translation because it transcends speech itself. As you contemplate these mysteries, remember that the pyramid was not built in isolation. It represents one node in a network of knowledge that may have once spanned the globe. The same mathematical constants, the same astronomical alignments, the same reverence for cosmic order appear in monuments from Stonehenge to the American Southwest. Whether this represents independent discovery or cultural transmission, the pattern suggests that ancient peoples shared fundamental insights about reality's mathematical structure. In 2017, the discovery of the void above the Grand Gallery using muon tomography reminded the world that Giza still holds secrets. This hidden chamber, inaccessible and unexplored, might contain artifacts, inscriptions, or simply empty space designed for purposes we cannot yet comprehend. Its existence proves that even after centuries of study, the pyramid continues to reveal new mysteries. The void's placement appears deliberate, positioned at the pyramid's center of mass with geometric precision. Some researchers speculate it could be a pressure relief chamber, while others propose it might serve acoustic or electromagnetic functions. Until exploration technology advances enough to investigate without damage, the chamber remains speculation's canvas, a reminder that human knowledge always remains incomplete. This incompleteness may be the pyramid's most important lesson. In our age of rapid technological advancement, we sometimes forget that progress is not inevitable. Knowledge can be lost as easily as gained. Civilizations that seem permanent can vanish within generations, leaving only fragments for future archaeologists to puzzle over. The builders of Giza understood this fragility. Living in the shadow of global catastrophe, they could see how quickly the familiar world could change. The Sahara was drying, the Nile was shifting, and oral traditions preserved memories of even more dramatic transformations. They built not for their own glory, but for continuity, encoding essential knowledge in the most permanent materials they could imagine. Dr. Mark Lehner, despite his conventional dating preferences, acknowledges the monument's enduring mystery. After 40 years of study, the pyramid still surprises me. Every measurement reveals new relationships, new mathematical harmonies. Whether intended or accidental, these patterns speak to something profound about human nature. Our need to create meaning through precision, to connect earthly work with cosmic order. The pyramid stands as proof that this connection remains possible. Even in our secular age, when scientific materialism dominates academic thought, the monument continues to inspire wonder and speculation. It reminds us that empirical knowledge, however precise, cannot fully capture the human experience of encountering the inexplicable. Perhaps that encounter was always the pyramid's true purpose, not to serve as tomb or temple, but to generate questions that transcend easy answers. To force each generation to confront the limits of its understanding and acknowledge that mystery remains an essential component of existence. In a world increasingly mapped and measured, Giza preserves space for the unknown. The night deepens over the plateau, and Orion climbs higher in the sky. His belt still points toward Giza as it did when the monument was new, though precession has shifted the exact alignment. The stars that guided ancient observers continue their eternal dance, indifferent to human theories about their meaning. They remind us that some truths operate on timescales that dwarf human comprehension. Standing before the pyramid in this cosmic context, you feel both humility and connection. Humility before forces vast enough to move continents and melt ice sheets. Yet connection to the human impulse that created something capable of enduring such forces. The monument represents neither conquest nor submission, but partnership, an attempt to align human purpose with universal principles. The desert wind carries sand across the limestone blocks, the same wind that has blown here for millennia. Each grain represents countless cycles of erosion and deposition, breakdown and reformation. The pyramid endures because it was designed in harmony with these cycles, not in opposition to them. Its builders understood that permanence comes not from resistance, but from resonance with eternal patterns. As the temperature drops and the stone begins its nightly cooling, you can almost hear the monument breathing, a slow, deep rhythm that matches the pulse of the earth itself. Whether this sensation is real or imagined matters less than its effect. For a moment, the boundary between observer and observed dissolves, and you become part of the pyramid's ongoing conversation with time. In the end, the Great Pyramid stands as proof that memory can be made physical, that thought can endure in form. Its stones contain no words, yet they have spoken longer than any text ever written. Whether built by dynastic Egyptians, survivors of a global catastrophe, or inheritors of even older wisdom, it remains humanity's most enduring statement that knowledge, once understood, never truly dies. The stars wheel overhead in their ancient patterns, and the pyramid maintains its perfect orientation through all celestial change. It points always toward the true north of both earth and understanding, a testament to those who built in harmony with eternal laws, leaving behind not just monuments, but invitations to remember what we once knew.